Hi, my name is Anton, and today I want to speak with you about current state of car license plate recognition. The current year is 2022, and I hope that this video will be actual for the next few years. Car license plate recognition is one of the earliest tasks of computer vision. But the algorithm 25 years ago and current algorithm, they are completely different. I will tell you a bit about the history of this task and a lot about modern algorithms, what algorithms you should use, what problems you will meet, and how to overcome these problems. But before we start, I want to ask you subscribe, not only on this YouTube channel, but also on my LinkedIn or on my Medium or on my Telegram channel, because a lot of contents that I create not as YouTube video. For example, this YouTube video is created based on my Medium article that I published about a week ago. And for some articles, there will be no videos. So if you're interested in this type of content, just subscribe on different platforms. So let's start about the history. I totally missed the dark ages when number plate recognition was without any learning parts like HAR or HOG. People usually used handcrafting features at that times. I used such methods only in other tasks like iris recognition. For the first time, I and my friend created a license plate recognition system in 2012. There was no neural networks, HAR to detect and then correlation. Such approaches began to appear in 2008, 2010 and were relevant until 2014, 2015. In 2014 and 2015, we created a system for recognizing numbers on trains with HAR-like feature for detection and neural networks for characters recognition. These were the years of transition from old algorithms to new one. In 2016, when neural networks were already everywhere, we created a recognition system based on neural networks and use it for car plates and container numbers. Looking at it now, it seems to me that it was very simple and very primitive system. We use Cafe, by the way. From 2016 to 2019, many solutions start to migrate to the edge. Jetson, Intel-based, Raspberry Pi, Rockchip, and many others. And in 2020-2022, approaches has changed. Solutions have become more product-oriented, predictability and stability have become more important. Not only the final accuracy and inference device is important now. Today we need to know how the system will adapt and improve with new data. We need possibility to retrain system and to check new accuracy on production. So that was the history part. Let's speak about modern algorithms. But when I will tell you about which networks to use or something like this, I want to tell you more general ideas. And these ideas about pipelines that are often used in number plate recognition. The pipelines are the same for train numbers recognition, container numbers recognition, and of course for license plate number recognition. And the pipelines can be very different on different platforms and for different tasks. When we are speaking about car plate recognition, of course there are tasks for recognition or on mobile phones and task for recognition or speed control systems, and it's completely different. First, let's generalize and look at the most common pipeline, and it looks like this. First we detect the car, next we detect the plate, next we normalize the plate, next we detect different or recognize the full plate, and we have our number. But the actual pipeline pretty often they're completely different. And first let's speak about different tasks, and then speak about pipeline in each of these tasks. First task, license plate recognition on the phone. People often use this for filling out some fine protocols, checking car in the parking, or for speed up some process like car selling or something like this. The second case, recognition at the entrances to some parking or some shopping center or on some private territory. Third task, recognition on the road, like some speed measurement, like some other incorrect driving, like crossing some marks or not turn on some lightning and so on. And the fourth case is recognition as API. When you create some systems and can work in different case for different location. First let's speak about license plate recognition on the phones. For this application, it's usually not necessary to detect cars. The license plates are large, but the rotation can be a problem. Numbers can be rotated even 40 degrees, even on pitch, roll, yaw. The algorithm usually look like this: number area detection, number angle recognition, and after you rotate the number and normalize it, text recognition. The next, recognition on some entrances. Usually it's mid-size recognition when only 2 or 3 cars in camera. Logic usually like on the phones. Cars are usually close to the camera, but there can be several cars in the frame, so you need find the position of some specific cars. And as a result, sometimes it's necessary to additionally detect the area of the car. So the algorithm will look like this: car area detection, number area detection, angle detection, and text recognition. The next one is recognition on the road. In speed control system, it's usually necessary to know the maximum parameter, but you need to remember the installation place is known, It's not necessary to have a model trained for 100 types of numbers or a few thousand type of orientations. Processing speed is very important. Sometimes one computing unit can serve a number of cameras at once. As a result, the entire model should be optimized for speed. First, cars are searched at a low resolution, then the license plate area at slightly higher resolution, and then the license plate is directly proceed. So, the algorithm should look like this. First, vehicle area search. Second, number area search. Third, place orientation recognition. Fourth, text recognition. And fifth, number parameter recognition, quality, country, overlap, and so on. But sometimes you can switch place of some of this algorithm. For example, you can merge plate orientation, text recognition, and number parameters recognition. API recognition. Such system usually require good quality for any type of input. So you need to use best models. And such models are usually pretty slow. But you need to use not only your best model, you need to use a bit different models than other type of recognition. For example, usually you need to create some model to define which data domain you want to recognize. For example, is it full frame with a lot of cars, or maybe it's some crop with high rotation in it? You need to estimate which country you are working with, because it's pretty hard to create models that have similar power for some Asia region and for North America region. So usually API recognition will be very slow and will have a lot of different models. Now, after we speak about architecture of our pipeline, let's talk about internal algorithms. So, and as you see, the most common algorithms is detection. So let's speak about detection and a bit about rotation. In 2022, it's difficult to say something fundamentally new about detector, especially in such task as number detection. It's a very simple task. The problem was solved quite well even with hard cascades. But it seemed to me that it's necessary to pay attention to several things. This task for detecting license plate is easier to solve on small resolution. It will have same quality and improve performance. The complexity of the detector, of course, should be determined by the condition of use. To work on the API when you have completely different plate type, you need to take powerful detector. But for remaining application, usually even mobile net SSD is enough. And of course, at the moment, Yolov5 will give you pretty good result and will be pretty fast. It's possible to use detector with some additional anchors for rotation. As example, you can look on mmRotate library. But in mmRotate library, you can rotate only on one direction, so around central point. It's not very good since the car number can be tilted in different plane. As an extension of this approach is to append 4 different corner points to the detector. It will be similar like retina face. And of course, you can use this approach to detect as one shot both car plate and car plate orientation. You can even append some text recognition in this one neural network, but usually it will be pretty hard to train, and it will work pretty bad in constant development system. So about our experience, we prefer to use detector and some additional neural network for rotation. Sometimes we combine rotation with symbol detection neural network. This make it possible to better control the neural networks and they result on different stages of training. And when a new partially labeled dataset appear, we don't retrain everything. We retrain only one part of this pipeline, only one network. But you can use any way, and for some task I show the detector with 4-point will prefer. Text recognition. For text recognition there are several different approaches and even some combination between them. We have used all of them. At least we tested it on some of our datasets. Let's look at them in more details. And the first approach is most classic one. Let's extract some feature map with backbone, slice it as a temporal sequence, and link this temporal sequence with target number. 7 years ago, such approach work with CTC-loss. So you sequence the temporal component, put it in some LSTM neural network, and output to CTC-loss. I saw that someone even done this without LSTM neural network, and it worked quite well. You can find some modern version of this approaches in OCR or Paddle OCR, and there are a lot of different OCR engine when you can work with this. This is most classic approach. But let's speak about minuses of this approach. And the first minus is very big. When you train it on some data set with a lot of sequences that look pretty same, for example, they have at start ABC. But in practice, you meet some sequence when you have not ABC, but something like APC. Such approach will try to correct you and write this number as ABC, even when the P is pretty good looking. Even if you have a lot of symbol P in some different number part. So it's the first problem, and it's pretty hard to cure this problem. The second problem with this approach is with some texts on plate numbers that have more than one level. For example, 2 level or even 1.5 level. Such number are pretty often on some Middle East. And with such number, you need additional neural networks that will detect different lines of text and their location. And after that, you need to use your neural network to recognize the whole line. But you will meet another problem, because some part of number will be pretty small and some part will be pretty big. So probably you will need to train different neural networks. And this is the most classical problem for this method. And the second problem with this method is LSTM and transformers are not very good for an edge. So after you train such network, usually you need to locate it on some edge devices, except you're creating some API. And such neural network is pretty bad for transcription. But as I mentioned above, you can create such network even without LSTM part. But okay. Second approach. The second approach is neural networks that are iterative, and this approach is end-to-end usually. The neural network predicts the position of first symbol, then it's predict position of the second symbol, and so on. Here you can see some example. The cons: you need a large data set for training. For some of the methods, it's necessary to mark even special position of the letters. Some of these methods are pretty long to compute, but definitely there is some progress, and a lot of new methods appear. But I didn't see anything very consistent now to work with and to locate this method on the edge. Usually they are or pretty slow, or the pipeline is pretty unstable. But I think that this approach will rise in the next few years. The third approach, recognition through attention. There are few different approaches to this, but the main idea: you classify number on which symbol do this number have, and after this classification you look at the attention map and find the location of the symbol. We create this method in 2016 and use it for a while. This method is very cool to work on the edge. This method is require pretty slow amount of the data set, but it's not very comparable to the new methods in case of quality. So we didn't use it last 2 years, I think. But our solution on this method already in production, and they work quite good. But in this, for the now, I do not recommend to create new system based on this method. The fourth approach, I think that it's more straightforward and the best approach when you have some money to labeling. You just need to use some detection or segmentation. You labeled all symbols in your number and work with them. It's work amazing. But you need a quite big data set with good representation of each symbol in your alphabet, and sometimes it's pretty long to create. It's work well with an incomplete task. You can append a new symbol in your data set, and it will not harm your training process. Of course, this method is quite good for an edge. Very easy to port something like UNet, of course, but of course you don't need to use UNet today, but some segmentation network definitely will work good. These methods are excellent for debugging. You can see all your problems just looking on the result. And sometimes you can find that this method not working because some shadow problems, so you need to append some examples or create some augmentation with shadows. So excellent method. But as I said, we used all of the approaches. For large and finished task, best is first approach and the second one. For developing product, the best the fourth approach, and for small data set, the third approach when you use attention. But to choose which approach do you need to use, you need to look at both on the platform that you want to use, and you need to test your neural network first, of course, before you will train them. You need to look at working criteria. For example, is it possible to work longer with some numbers, or do you need very good speed? And of course, you need to look at your data set and the amount of computing capability in your device. Okay, let's stop the theory and speak about working examples. Today you can use already created neural networks for car recognition. I do not recommend to work with such networks in some project when you need very good quality and you need ability to improve this quality. But if you have very low budget to work with, you can take something that already working. And the first working solution is Nvidia TAO. The minuses is it's work only with American or Chinese numbers, and you need Jetson or Nvidia GPU to work with it. Also, I need to mention that the quality is not excellent, but it's work from the box if you work with American numbers. The second working solution is OpenVino. They have only Chinese plate numbers, but this solution, in my opinion, work a little better than Nvidia TAO, but they, as far as I remember, they don't have retraining pipelines in this solution. So it's good if your task is the same that the solution can give you. The third way, you can use open source projects. There are a lot of different solutions on GitHub. The most of them are pretty bad. No support, usually only Chinese plates, pretty small data set. But there is one good solution here. It's pretty funny because we worked with these guys, I think, 7 years ago and provide them some online recognition. But after that, this team create their own solution and they realize it open source. And the solution is pretty good in my opinion. It's not excellent. For example, you can improve it by creating some additional neural network to decide car plate orientation and to change text recognition neural network on something more stable, in my opinion. I saw one article that where different team made this and they have improvement of quality, but they didn't provide the sources. Also, there is fourth approach. Just take Yolov5 or another pre-trained neural network to detect the cars. And after you detect the cars, just use something like OCR, Paddle OCR, or Easy OCR to recognize all the text in the detected cars. And use some templates to choose which text are numbers and which text are not. This approach is very easy to do and it will work with a lot of different countries and with a lot of different car plate types. I hope this video helped you, and if you want me to tell more about some car recognitions like speed recognition or about some edge problems and how to solve them, just ask me in comments and probably the next video will be about this. So, goodbye.